Thank you for the introduction. Again, thank you very much, everyone. Good evening. Thank you for welcoming me here in Cluj once again. Today we are going to talk about Java because it's part of my community now, and security because I think security is paramount. But what about you? Who thinks security is important here? A lot of people, no? Impressive number of hands up. Now, who's a Java developer? Again, quite a few people here. And now I'm talking directly to the Java developers. Who of you know how to use the Streams API in the JDK? Only a few hands? I don't believe you. I want to see all the Java developers say, okay, who knows how to use the date and time APIs? Okay, some hands again. Who knows how to use the security APIs? Almost no hands. Okay, so this is a little bit paradoxical and is the result in all the places I have delivered this talk is that it seems that most of the Java developers know how to use Streams API, knows how to use date and time API. Even when I asked about Reflection API, the majority raised their hands and they know how to use it. But when I ask about the security APIs, the majority of the hands are down. And I'm curious, if we all believe that security is important, why is the security API module in the JDK the least that we want to discover? Wouldn't be that one part of the first that we should know, because we know security should be applied from the very first stages of the development of a system, of an application, and so on and so forth. I'm Laurentiu. I'm part of the Java community in Romania. If you already know me, it might be because either of my YouTube channel or one of the books I wrote, and because I'm also very active on social media, so I advise you follow me if you're interested in Java topics. And of course, I hope to see you also in different other, with different other occasions. I also usually come with presents, and I have one book here that I will give at the very end. It's one of my books, Spring Security in Action. Who knows Spring Security in Action? A few hands, okay, thank you. I'm glad to hear that. And I want to say that today's talk, I stole a few diagrams and a few ideas from one of my friend's books, Software Security for Developers. Adib is one of my friends. He's working for Broadcom, and he's writing this book now. It is already available as an early access, and I will be co-authoring the book as well. I will be writing a few of the chapters. The book is a lot more complex than what we are going to discuss today. Today I'm going to tell you about some of the things we can use from the JDK directly. But in the book, you also discover stuff about Jose implementations such as Nimbus, OpenID Connect, OAuth 2, and different other standards and protocol and best practices. So in case you like the diagrams in my presentation, you might want to, to take the book as well. So first of all, I want to be aware on where we are. We are talking about application level security. So we are the application developer because security is such a wide domain, and it starts with the mathematics of implementing the cryptography algorithms up to the auditors, assessors, and of course the hackers are part of the community as well, why not? But in this presentation, I'm going to discuss about the low-level bullets, the low-level objectives of security. And we can shortly name them as integrity, authentication, confidentiality, and non-repudiation. And what I want to prove in today's talk is that we can have all of this only with what the JDK provides us. And why I want to stress this out, and this will be basically a lot of stuff, because you might want to, you might say, okay, that's just a few points, but we talk about cryptography, and all of this come with a lot of things that we find as part of the cryptography. But the reason I want to stress this out is because in many cases I have observed, and I mean throughout projects I've been involved in the past many years, I have observed that at least in what concerns security, but not only, we are very tempted to look over the wall into third parties rather than thinking on what we already have. And I have seen many applications using different third parties, such as, for example, Google Think, Apache Shiro, and others related to security, with only small implementations that could have been done directly with the JDK. Now, you might ask, what is wrong with that? What is wrong with choosing to use libraries instead of using what's in the JDK? In the end, as long as it's open source and the license allows me to do that, I can choose to use whatever I want. But the point is that we have to be a lot more aware of how our applications work today and how are they deployed, how are they delivered and used. And it's not only about security, but think about all our applications today. We do put them in containers and we run them in clouds. In many cases, we make them as small as possible, and we have small components that we then horizontally scale with different practices and different technologies now and run them in different kinds of clouds, some of them public, some of them private. And the cloud, I'm not sure about all the possible characteristics of clouds, but I know one for sure. And I'm pretty sure it's true with all of them. And that is, the cloud is expensive. So I don't think you will find a cloud system that can be called cheap. So our purpose is, one of the purposes when we architect applications in cloud is also to make them as costly efficient as possible. Of course, we talk about performance, we talk about security, we talk about all others non-functional requirements, but we want to make them also less costly when we deploy and run them. That's why, for example, a horizontal autoscaler might scale up some pods, but at the same time, it might be implemented in such a way in which it scales down the pods when we don't need the applications anymore, because we want to make them economic. Now, you make your applications less costly in different ways. One of them is also minimizing the footprint of the application, no? So the more dependency you add to your application, the bigger your footprint is, and then in ways, the more costly it becomes in a way or another when you deploy them. And the thing about this is that it's not like easily sensitive, because when you implement as developers, when we implement applications on our own machines, we don't see that. You've added a dependency, was that only 4 rows in your POM XML file if you have, for example, Maven as a build tool. You put it there and you don't even observe that you have actually added, like, I don't know how many megabytes already, and then you only use it for one function or one method. I've even seen cases where a whole dependency was added for only a usage of a constant in the whole application. And that's an anti-pattern. That's wrong. We shouldn't do that. And we shouldn't do that either with security. So what I'm thinking, when I'm thinking as an architect, I'm always making the assumptions and considerations of everything that I consider to be a compromise. That means if I add a third party, I add it because I really need it, because it brings something that I need and don't have. And when I add a third party, I know that I really need that third party. Well, that's so decreased app footprint, but you also have simplicity, no? The more dependencies you have, the more possible gates and vulnerabilities you might add to your application. You don't even know where the vulnerability jumps from, like, for example, Log4j a couple of years ago or something like that, no? So the less dependencies you have, the less code you don't know in your code base, the less code you might not have tested in your code base. So automatically also an increased trust. So you see, only by adding dependencies related to security, because you want to secure better your application, you might actually secure it less. That's why I promote using what you have in the JDK, which has an increased trust, rather than adding something from outside if you don't need that something. Of course, I don't want to say that third parties are useless or something like that. No, we do need third parties. Sometimes we want to use them, and there are strong reasons why we want to add them to our application. But we should always think about, do we already have what we need? If yes, then let's use it. Do we already have hashing in the JDK? Can I hash this string using SHA 512? Yes, I can. Then let's do it without using a third party, and so on and so forth. So let's talk about what we have and how you implement it, and let's talk about also why this security API is difficult to understand at the very beginning, but in fact, it's not that difficult to use. And I have observed also through asking, in general, one-to-one, different of my colleagues and collaborators about why didn't you use the security API in the JDK, and the majority told me that they found it difficult to use at the very beginning and they didn't find enough documentation. Today I will prove you that it has a few problems, but it's not that difficult to use. And one thing I know about the security APIs in the JDK is that they are taken care of, and with any new release, a new Java release, you get new algorithms, and some of those that we shouldn't use anymore are going to be deprecated, which means it's continuously evolving. It's not a dead module, it's continuously evolving, and it's always meant to bring you what you need to keep your application secure. So one of the things that you would use, for example, is hashing. I was talking about hashing earlier as well, and I started with this because I find it to be the simplest to understand. And I don't have a code example here for this one. I want to show it to you directly in my IDE, because you will not believe me it's Java if I don't show you it's Java. And I want to discuss a bit about this code with you. And it might look not really clean. And let's take it one by one. So first of all, and you will observe, I will not go through more examples when we discuss about encryption, signing, MAX, and so on. I will not show you any more code because you will already understand it. That's what I find nice about the security APIs in the JDK, is that they are at least on the same pattern implemented, so that if you understood how to do one of the action, you know how to implement the others as well. For example, for hashing, you have a manager object called message digest. You use that factory method, static factory method called getInstance. You provide the name of the algorithm you want. You get the manager, and then the manager has a method that knows how to operate using that algorithm. What is good here is the simplicity. You can see that I can apply this operation with only a couple of lines of code in the end. What is bad about this is the initial design that has been taught at the very beginning, when some of the things that we know today weren't, let's say, we weren't so much aware of them at that time. And because Java is meant to be always backwards compatible, preferably as much as possible up to 100%, some of the things have been kept up to even the current version, which is Java 23. So what is bad about this, first of all, is that string there that we have to provide as a parameter to getInstance. I will tell you later why we have a string there. But the point is that the fact that it's bad is that you can actually put anything in there, no? Question is, how did I know that I can write SHA 512 and it will work? And then what else can I put there and pretend it's working? Can I write any kind of string there? Of course not. If I'm writing a string that getInstance won't understand, I will be provided with an exception. You see that throws exception that I put on main, it's actually hiding an exception that's called no such algorithm exception, and I had to throw it because it's a checked exception. So a checked exception in Java is that exception that you either treat or throw, otherwise you won't be able to compile, which is another bad design, but I'm discussing that in another talk. So aside for that, the things are very simple. You get that manager object, you call the method, you get the result, which is that digested array of bytes, and then you can do whatever you want with it. In my case, I hex encode it, and if I want further, I can even base64 encode it, for example, if I want to give it a shape in which I can easily either transfer it or store it in a file. Going back to my presentation, so the same you can do with absolutely all of them. Now I'm gonna make a summary on what hashing is. And hashing, because you saw that it's a cryptographic function, it's a cryptographic operation that allows us to change an input to an output in such a way in which you cannot change back the output into the input. And this can be used actually to get that integrity, which is one of the 4 points that we have seen on the slide at the beginning. Why? You have some information, you compute the hash over that information, and then you send the hash together with the information. If the hash at the other end doesn't correspond to the data anymore, it means that the data has been altered throughout the way. Do you use that on a daily basis? Who uses that on a daily basis? I promise you, all of you use that on a daily basis because you use Git. Who uses Git? Okay, you use that on a daily basis then. Okay, now you know. So Git is only one of the examples that uses this. But what hashing doesn't provide you is actually the authenticity, which is the authentication part. So the second point in one of the first slides of this presentation. It can only tell you if the information has been altered or not, but the problem with hashing is that anyone can rehash with the same algorithm the same data again. So that's why hashing offers you integrity, but it cannot offer you authentication. Someone could have changed the data meanwhile, but also recompute the hash. And in that case, you will not know that it has been altered. So hashing might only be used for chaotic events where the data has been changed for any reason, but not because someone tried to change it, because if a hacker would try to change it, they would also be able to change the hash, and then you would still end up with wrong information. To be able to offer authenticity, you use a MAC. So the message authentication code, short MAC, uses also a secret. So you cannot, it's like a hash, but with a secret to make it easy to understand. So you cannot recreate the hash unless you have the given secret. So in that case, you add both authentication and integrity if that's what you want. Now, I want to discuss this code, which I now pasted into my presentation. But since you have already seen in my IDE the previous code working that was generating a hash, what I want to prove actually with this one, that you have the same pattern. And if you did understand the code that I have previously shown you, now you do understand how I generate the HMAC as well. You see, it's the same pattern. I get a manager object, I use a factory method, I have to provide the string that gives what I want to use to generate the MAC. In my case, I want to create an HMAC with SHA 256 as a hashing method. But what's different, of course, than just creating a normal hash is that in this case, I also have the secret. In my case, that string pass, which of course should not be that in a real-world application, and that you should keep secure in a vault. But you provide that secret, and then only if you have that secret, you can recreate the HMAC. And that gives you not only integrity, but also authenticity. So these were the 4 goals that we discussed at the very beginning: integrity, authentication, confidentiality, and non-repudiation. And using SHA 2 or 3, which are the accepted standards now for hashing, you provide integrity. using an HMAC, you provide both integrity and authentication. Now, do we have in the JDK resources, functionality, capability to also provide confidentiality and non-repudiation? Yes, we do have that as well. We can create asymmetric key pairs, and we can either encrypt using asymmetric key pairs or sign. Encrypting would give us the confidentiality, because encryption is a way in which we change the data such in a way in which only someone who knows a specific secret, usually in this case the key, what you call it, to get the data, and the non-repudiation using digital signatures, because we can sign, and then by signing we somehow say this is us, we have created a specific information. And again, we do observe the same pattern. So I have already made you experts in how to use the security APIs in Java, no? Because you already know, you just now need to know the classes, and you already know we need to get a manager object, we have to provide the string that gives the algorithm we want to use. For example, in this case, we want to create an asymmetric public-private key pair using RSA. We do have to initialize to provide the key size in this case, but then we get the pair, and depending on whether we want encryption or signing, this is encryption where we use a cipher, we get a cipher, and we can provide a transformation that will be used by the cipher to encrypt the data. Okay, now and finally, I want to let you know why was this design meant to get those strings there, which is probably what we might consider the less unusual of the implementation of the security APIs. It's not clean. Now, if we go to the maintainability standard, we always talk today about clean coding, principles, maintainability. It's an important part of software development and software architecture as well. And then in this case, if you do this now, you might, but in general, it won't pass the code review, so it's not that dramatic, no? We have code reviews. You do have code reviews, no? So in this case, the reason, imagine this was the first Java version many years ago, no? So I want to ask you first, what would you do there instead of putting a string? Who wants to give me a solution, an alternative solution? Okay. An enum, someone says. Everyone agrees with the enum. Well, I will tell you why enum is not enough now. Enum is not a solution here. It's a better solution than string, but it doesn't cover everything. And it doesn't cover extensibility. The problems at the moment they have implemented this kind of API, first problem it was there were no enums at that time. Then, even if they were, it was not a complete solution, because you might want to implement your own algorithm for whatever you want, hashing, encryption. How can we allow you to encrypt to implement your own encryption algorithm or your own hashing algorithm? And when I say you, I don't mean that you should do that, you shouldn't do that, but let's say you build a library that uses something special and you want to have something that is not provided by the JDK. They, at that time, came with the idea that is very similar with what we have in the JDBC now. I'm going to make a parallel with the JDBC because I know that it's more likely that you understand JDBC rather than the security providers. The JDBC, when we use it, we have some interfaces, so some contracts in the JDK, and then what we have to always do to make them work. Can we have an application connecting to a relational database management system directly with the JDK? No. We need to add in our dependencies a driver. Agree? So that driver actually comes with the implementation specific to the vendor we are using. If you use MySQL, use a specific driver. If you use Oracle, use a specific driver, and so on and so forth. So the same idea here comes with the security providers. instead of having the JDK that provides you with all the possible algorithms, which would not be possible and not allowing you to create others, it allows you to add your own provider. And for example, in this case, probably the majority might have heard about Bouncy Castle. If you need something else that the JDK doesn't offer you, at the same time, if you want to implement your own. So for example, if you want to use Whirlpool hashing, then you have to use Bouncy Castle because the JDK doesn't provide you that out of the box. And there are other examples as well, and so on and so forth. Then in that case, you do add to your dependencies Bouncy Castle, and you will be able to write RIP MD160 as a string and get that kind of algorithm for hashing or encryption, or whatever you try to do. Now you know why has this been done like that, and you know why enums, even if they say would exist at the time when this was designed, were not really helpful. Can you, however, give me a better solution in terms of design? What is the class name different to a string? Okay, fine enough, but if you need a class name, then you need to have it at compile time, but in that case, you might have it only at runtime, so you might not have the class name. So you run back to a string. So it's not a complete solution, unless you assume that you always have that class at the compile time. But let's say you don't have it. Let's say you might have it only at runtime. You're close to, and factory, you're thinking at the factory because of the interface that the factory returns, okay? With an interface. A better design here would have been providing a given interface that represents that specific algorithm. Then you can implement it, and in order to have a specific algorithm of a kind, you know you have to implement that interface. It could have even been a marker interface, that one with no methods, but it's still better than giving a string. Then you would only be able to use instances of objects that implement that interface, that implement that contract, no? Okay, but let's not go there, because as I always tell, and I have a separate other presentation for that, code that you today write might not be considered the best, I don't know, 6 years from now on. So I'm not here to blame the way in which this was created, because at the time, this was the best way to write the code. So we don't have to judge that. And that's because, again, for you, you don't know, even 6 months from now on, what will happen when you will read your own code in your specific code base. But then, just to make a recap of what we have discussed, so you have your application code, and then you have the JavaX security packages. They give you somehow, imagine, like the JDBC, like the Java SQL from the JDK, they give you the contracts, and then you might have several implementations, some of them like the Sun JC provider, which is provided with the JDK, but others like the Bouncy Castle, which you can add by yourself in the class path if and only if you need it. And again, this allows you the possibility to avoid using Bouncy Castle if you don't need Bouncy Castle, because in many cases, I see Bouncy Castle in the dependencies in projects, and then I don't find out any real Bouncy Castle usage there. And it really happened at some point, and I asked the team, and the answer was, that's how it has been in Stack Overflow, so we took it from there. We didn't ask ourselves questions. Why should we put Bouncy Castle if we should? We should. That's what is there. Now, that will happen, still happen. It's not with Stack Overflow, but with ChatGPT. It will still happen. Okay, and we have symmetric key encryption, and you see the same pattern. And I'm gonna now be quick, because I don't want to lose all the time with that. But there is one question that I still want to answer. If I'm talking about this transformation here, or even the algorithm there, maybe now, okay, we don't have an interface. We found out we could have had a better design, but we don't. So what should we do? How do you know that I can write there advanced encryption system, CBC, with I don't know what padding. Well, there is only one answer. You have to check the documentation. So to know exactly for what version of Java, what exactly can you use, for example, as a transformation or as an algorithm, the only reliable way is to check the official documentation. Okay? So these are examples now on this slide that you could have used there, which, by the way, you see this one here. This, when I only say advanced encryption system there, it defaults actually to one of that because it also needs the transformation and the padding. And as far as I know, it will actually default to CBC with no padding. But that's one more of the bad things that happen when we use this kind of approach, because now I actually, if I write it like that and I copy it like that from my Stack Overflow, for example, I might not even know what kind of transformation, what kind of padding I'm using, which might be actually very important to what I'm doing. But we have seen that this way we can implement integrity easily, authentication, even confidentiality, and the next is, of course, you can also have non-repudiation, and that might happen and might be the best approach even without any other dependency in your class path. Okay, that's the main of the things that I want to deliver to you. I want also to add a couple of more points that might be relevant. They are still related with the security API, and you might want to know about them. And this will be as an ending of my presentation. So you might have heard, okay, about security manager and policy files. If you ever read any kind of material about the Java security API in the JDK, you might have heard about this. Don't make a confusion between the provider and the security manager. The security manager is something that is deprecated nowadays. You might only see it in very old code base. So with that zip there, I have copy-pasted for you the URL. You find out more details about the deprecation of the security managers in Java. Policy files, however, they might still be used. I like sometimes to use them. It seems that we forgot that this kind of capability exists today, because today, as I said, we are very often using containers to deliver applications. So it's very easy to see the container as the whole, as the atomic, the atomic object, and you don't look inside the container. So in many cases, you try to, if you want to test, for example, that some kind of permission works, you test it through the container directly instead of thinking about the application anymore. But if you want to independently refer to the application, to the Java application, then policy files are a way in which you can test what and how your application, what it does and how it works when you have specific restrictions. So imagine you want to test that your application behaves in a specific way if it has or it hasn't access to a specific path in the file system, or it has or it hasn't access to a specific URL, IP, DNS, whatever, without changing the application. And this is a way in which you can do that. Alternative is, again, today we very often implement this kind of security checks directly at the container level. But in case you want to do that, it's of course more granular than the container. It allows you to test your application and only the application under certain scenarios. And it's completely decoupling it from any other part of the system, like even from the container in which that application runs. Okay, some conclusions, and then I'm gonna put you a QR code on the screen. I would like you, whoever wants to have a chance to get that book, to scan it, and of course I will also leave room for the questions at the same time. So, very quickly, we have to be aware that part of the security exists in the JDK. Use that whenever you can. You don't use that only if it doesn't, if it really doesn't help you. In that case, you might use any of the dependencies. The system, the capability was made extensible, so you can extend it with different dependencies by simply adding them to the class path, but you can also, you would be able to implement your own. I don't advise you do that, but you could. I do believe that security APIs really are an excellent part still, even if we saw it might have its flaws in the design, which today we might see them as non-compatible with what we learn as best practice in the maintainability classes. It still is a very good tool. Now, I'm gonna again tell you once more that you can find me online, and I want you, if you want to get this book here, to scan that QR code and put your name. And while you do that, I'm gonna also take questions.